All right, let me start here. My name's Jim Aniskevich. I'm in charge of the automation group at Spirent. So Angus was up earlier. We were all one group until a few months ago, and then there was a bit of a reorganization at Spirent, and this group now is focused on automation. We work very closely with Paul, and in fact, some of the things you're going to see in here are ideas that Paul already touched upon. So I want to try to keep this a little bit interactive. And this is a slide that we show, say, anybody who's doing anything, whether you're testing, whether you're deploying, whether you're building something, whether you're designing software, automation helps you. But where do you think you should start if you're going to automate something? If you look at this quadrant. So on the y-axis is something that's simple to do is low, and something that's complex to do, like setting up many things, going through a lot of different tasks, moves up the y-axis. And how often you do it is on the x-axis. So if you do it fairly often, for example, daily, it's to the left, and if you do it not so often, it's to the right. So where do you think you should start? Anybody guess?
Simple, frequent things is the easiest place.
Exactly.
If I should do it more than once, I should automate it.
If I'm a proper automator, I'll spend 4 hours automating a 10-minute process that I do once.
If you do it very frequently and it's simple, that's where you want to start. Now, why do you want to start there? Well, you want to start there because you get those things out of the way, so you don't have to worry about doing them manually anymore, and you save time, so that now you can move to the next spot, which is something you still do fairly frequently, but it's more complex. And then the third area you want to focus on is the things that you do less often, but are simple, because those are going to be easier to automate. And the toughest items to automate, the things that are complex, but you do very rarely, that's the last thing you want to automate. So those are where you usually keep for manual testing. Now, a lot of companies that we talk to start in the exact wrong place. They start in number 4. And if you start at number 4, you have the problem of, hey, you're spending a lot of time automating something you don't do very often, and you say, hey, automation isn't valuable to me. So if you start in the right place and you build your automation task, you build your library of assets, if you will, and automation assets, then you get to the first step, you get that done, and you free up time. Then you start seeing return on investment. And I have a little demonstration here to illustrate ROI. Who has a dollar bill? First person to show me a dollar bill. I'll help demonstrate ROI.
Coin.
All right, he has a dollar bill. He's going to give me that dollar bill. I'm going to give him a $5 bill.
I like this deal.
I got a dollar now.
Exactly. So when folks start learning about how ROI works in automation, you want to get in on the game. And that's what we see. So when folks understand, hey, I understand what I should automate, where I should start. Now I understand why I should automate. Because the payoff becomes very obvious very quickly. And I start seeing return on my investment in my automation infrastructure and getting started in automation. And what Spirent has is the tools and the products to make automation easy. You'll see a little demonstration of that a bit later. So I have a few examples in here, and these examples are around specific customer scenarios. So this can apply to almost any industry. So this specific one is looking at a customer that was certifying gateways. So this could be in a large enterprise, this could be in a service provider. It doesn't really matter. If you have to do something many times, this is how it can save you money. So this particular customer had a long test cycle for verifying these devices they were going to deploy in their network. They had a lot of bugs that they saw that were being released. It was mostly manual testing. So if you have anything you're doing that's a lot of manual testing, automation is going to pay off. They had a lot of ambiguous test results. They weren't documented well. You have files, you're not exactly sure what they mean. So the results weren't clear and well articulated. They weren't doing a lot of end-to-end testing. So they were either doing subcomponent testing or only partial. And they had a lot of duplication. So they had some labs that were doing the same thing as other labs and manually repeating it, wasting a lot of effort. And then recabling, manually setting things up. We also have solutions that help in a larger lab environment to automatically cable things up for you. So this is how you approach automation with Spirent solution. And the idea here is you take these manual test cases and you create an automation asset, or that first step, test case creation. So you have somebody that went out and defined the manual test case. Now you want to take that and you want to capture it. You want to package that test case somehow inside of your automation environment. And what you have at that point in time is you have a replayable test case. So if you've captured it, now most of the times you do this, you're going to probably write a script. That's what most of the industry uses. But the tool we're talking about here, iTest, lets you take and capture that function or that step inside of the tool, and it's all automatic. So as you are executing the task that you're trying to do, you're also capturing it. And it's replayable. So it's an environment that you work inside of that looks and records everything you do. So that now, after you define your test case, that might be written up in the left. You just run through it once, you've already started automation. And that's what we call local automation. So that's something that the individual tester would grab. Now you want to take and you want to make that a hardened test case, which means you want to move that now into the enterprise and have other folks be able to reuse it. And what you do in that step is you add parameters, you add the ability to alter that test case by other users easily. And now you have what we call enterprise automation, which you can take those test cases into regression. So this could be used in a manufacturer, a NEM. This can be used in an enterprise where you're, like I said, evaluating, for example, devices that are going to be deployed. You have a core test logic, if you will. And that's let me hop one slide here. So you create this core test logic. Now if you're testing a switch, it doesn't matter if you're testing a switch from vendor A, B, C, D, or E. The core logic you're going to apply, you might test its MAC address capacity, you might test its forwarding performance, its latency, etc. Now you need to set up that switch, you need to configure it. That's the variable piece, but the core logic of the test you run, you design that once. And now you create the ability to run that core logic on many devices by using the technology we have inside of the tool. Response maps are a tool that says, hey, no matter how that device responds, whether it be a web interface, whether they change the way the command line interface responds from version to version, all you need to do to adapt and read the response from a different device is change that response map. If the way I configure the device changes, all I need to change is what I call the quick call. So I can abstract my interaction with anything I'm working with such that I make it easy to change and adapt to a new version of software on that device, a different device from a completely different vendor, etc. And going back to the ROI, here's the actual savings that this particular customer saw. So they saw a savings of $1.7 million a year in doing this gateway certification. They also saw a significant reduction in release time. So they had a major release, several major releases and minor releases that they try to get out the door in a shorter period of time, and they were able to do that by using automation, by eliminating the manual repetition. I can reduce, or this particular example, and this is a real example, I can reduce at least by half the time it takes to do the major release certification, and they went from 8 weeks to 4 weeks and got to 2 releases per year. And we're able to do 4 different devices instead of just 1. And they also had a significant improvement in minor release time, even higher. And they took it down by 3 weeks to 1.
How do you find that, because there's a lot of testing frameworks out there, obviously, and especially some of the the big CI shops, folks that are developing OpenStack and those sort of core projects, they already have a lot of tools that are already kind of baked in. So what's your sort of, how do you stand out, above those folks in sort of those integrated testing tools that come with a lot of the platforms that are already out there?
Right, there's quite a few tools out there, and there's a lot of open source pieces. What Spirent does is we actually work with those, not necessarily in competition with them. So, for example, Paul mentioned earlier Jenkins, and there's several other ones, and even our test tools and our competitors' test tools. We actually work with all of that. So our big difference is we're agnostic. And the other big difference is we have many different session types. So typically an automation environment might only be made for a specific interaction, like for example, a command line interface.
It's a very specific layer 7 top level application use case. It's not necessarily,
So we can,
outside of that.
we have many what we call session types, so we can no matter how your device is controlled or configured, we can configure it via command line, via web, we're also working on an OpenStack capability on this, as Paul mentioned. So a lot of different ways that we can interact with the devices, and that's our big differentiator. Is we're kind of a glue that can adhere to a lot of different pieces in this process. This is another example of a particular enterprise that was certifying or looking at evaluating and certifying or pre-deployment certification of different devices in their network. And these were different routers. And you can see, I won't go through the specifics, but you can see, you've gone from an ROI or a return on time or improvement of time of many X. In the first case, they were doing the Alcatel device, and they had several of them, 25 of these. They went from 25 hours it took them to go through this particular test case to less than 20 minutes. Now, Paul touched on this one, and this is, the example I have here is specific to a manufacturer, but again, continuous integration applies to any development environment. And this is an efficiency improvement that it realizes an incredible ROI. And for those that don't know what continuous integration is, and I think this is a repeat of Paul, but this is basically taking and constantly taking the software, the code that you're working on, and getting it into the main branch and making sure that it works with all the other pieces of code. And this is a problem that most organizations have if they are used to the waterfall process. They got all these different groups working on pieces of the software. When they all comes together, things start breaking. So if you're continuously testing these individual unit pieces and you're continuously putting things together and making sure that your check-in didn't break everything else, you have a pretty quick realization of improvement if you go into this process itself. So what our vision here is, we want to help, or we help organizations improve their quality, reduce costs, and shorten the cycles. And there's 3 ways we do this. So the context of this meeting is around virtualization. And we have a solution that plug into virtualization that Paul talked about. The orchestration piece here that I'm talking about works and manages a virtual environment, and that's a demo we'll do. And automation is obviously a key of improving any process or any development or deployment testing you're trying to do. But there's a challenge. So there's a lot of folks that have adopted continuous integration, but what do they find? What do they run into if they don't do it right? Well, there's a lot of different hypervisors that they might be using. There's the CI and automation software. So there's a lot of competing continuous integration environments out there that you have to work with. And having those things glued together is where the challenges come in. So you start seeing your engineering cost and deployment cost of putting in continuous integration become expensive. And you see a low ROI if you don't do this efficiently. And this can be complex. So the configurations can be complex, the workflows can be complex, and it requires expertise from folks that know how to do this. And that's where Spirent comes in, and our engineers and our services groups come in. As they've done this, they know how to do it right, and they know the pitfalls of how to do it wrong. Here's some particulars of a environment that we put together for a customer, and you can see the specific software packages that they're using. So iTest is in the middle. It's the glue that's pulling everything together, managing and running the automation. You're creating the test cases in iTest. Jenkins is used as basically the continuous integration engine, along with iTest to manage the VMs, where they're using Git as the source repository. So when a new artifact, whether it be a source code compilation or whether it be a test, when that gets checked in, it causes these other components to either spin off a build, and by spin off a build, the build actually doesn't have fixed servers there. So virtualization comes in, the servers get instantiated, the virtual servers get instantiated, the build environment gets created, the build happens, the artifact or the compiled code from that build gets put back into the source code, and then the test cases get kicked off. So this all happens automatically, and it's all orchestrated and engineered with these components. So here's an example of, again, another equipment company who was running into significant problems. They had a software release that had 4,000 bugs. They had very infrequent code integrations. This is one of the big pain points. And they were massive. So they would have a bunch of groups that were putting components or pieces of code together. And when that came together, it was difficult to isolate what broke. So was it, the encoder folks who were working on this piece of software, was it their problem? Was it the interface guys? Was it the engine? It was hard to figure out. And they were losing customers due to poor quality of the product they were getting out. So they estimated the cost that they were currently spending of about $12.5 million a year in CapEx to support their development and test environment. So they weren't virtualizing. They had a fixed dedicated build environment. They had a fixed, dedicated test environment. And that costs a lot of money. And they weren't able to reuse it, so a lot of it would sit there idle. So there was a significant CapEx that was being used for their build and for their creation and test environment. They were spending, they estimated $36 million a year in R&D just to fix bugs. Because of the poor process, they were wasting a huge chunk of money on R&D to fix these bugs. And they were also spending quite a bit of money on their QA department to maintain the tests. So they had dedicated engineers that were working on tests. They weren't pushing that test out to the development environment, or up to the stream to the developers. It was all bottlenecked into a QA department that was a significant cost center. And they had a lot of time to market challenges. They were losing customers not only because of quality, but also because they weren't getting enough releases out the door.
One of the things that we often see, especially you guys have a really strong enterprise portfolio, and that's great. And we typically don't want to dive into pricing on stuff, and because it's not necessarily what this is for, is talking about the technology of it. But where do you find the sweet spot's going to be for an organization to be able to make use of Spirent? Like, there's a lot of waterfall, we know, is pretty much gone by the way of bell bottoms now. Most folks are moving towards agile methodologies, so they're lining up with CI and how this is going to go. But what's the sort of size of organization you're seeing is latching on to Spirent?
Our initial successes were, as you can see, that kind of return or that kind of pain points is a large organization. But the model we're moving to is to enable organizations, even startups of just a few people, to actually be able to use this. So entry points of less than $1,000 per month.
Oh, wow.
For a user to get into this.
Great.
And again, this example is, again, a large example, so these folks are spending definitely more money than $1,000 a month, but their ROI is they expect to save $27 million a year in R&D. They expect to save almost, most of their QA budget. Remember, they were spending $4 million. They expect to save 3.2 million of that in QA, a significant amount again in CapEx, and a good savings in virtualization because of the way they're efficiently doing it and the way they're spinning up and tearing down VMs. They don't need to spend quite all the money there. The ones that are harder to quantify in dollar amounts is the amount of bugs they expect to see reduced, which is a 70% reduction, and the time between releases. This makes their customers happier, and it has a definite ROI, but it's harder to quantify. So these are the tools that we have. Again, I won't go into the detail on this. This is just reiterating what we said, but we have technology and expertise behind the EVCI process, and we also have the tools, which is our iTest family that has the test case authoring and execution environments, and also the lab management piece if it's either a physical or a virtual lab. Now this is my last slide. So this is what you consider what most folks would map continuous integration. And what this is I have a source code control, I do a build. If that build is successful, then I go ahead and deploy my test. If it's not successful, I notify the engineer or the division or the group that checked in that build. I deploy my test. If my test is successful, then, before my test environment, build the test environment, and then I run my test. If none of that is successful, then I notify. If it's all successful, typically this is where continuous integration stops. This is what most folks think of as continuous integration. And then eventually you push this into regression. But what we can do with this environment is we can also move to to further testing. So for example, you want this to be fast. The whole point of continuous integration is you want whatever you put on this left side to happen fast. If somebody checks in a new piece of code, you want that code to be built, you want some tests to be run on it, and you want to know if it's successful or failed. And you want that to happen in a 15-minute or half-hour kind of time frame. But if you want really hardened release-ready code, you need to still run that through a more rigorous regression. But with the tools and process we have, we can actually do the left-hand side and then at the same time integrate the right-hand side, which is, now that we know that that particular code didn't break anything, the basic test ran, now we can go and we can determine which other tests should be run. So for example, if I'm testing a codec development, now I want to use that codec development and I want to test it against a bunch of different video sources or on a bunch of different instances of a platform might be deployed on. So for example, I want to test it on a tablet, I want to test it on a laptop, I want to test it on a Mac, I want to test it on Windows, I want to test it on several different versions of Windows. You don't do all that over here. Over here you might just do it on one. Over here you now push it out and do it in a lot of different environments. So this is what we call continuous regression. So if you have an environment that can support the left, you can then move to the right, and this is where the other pieces of the tools come in, which is more complex scheduling, more intelligence of understanding what other tests should be run, and efficiently being able to run those tests. Now, just a little bit of info on what we can automate. Again, this is where iTest differs from a lot of the other tools out there, is that we can plug into almost anything. So web interfaces, terminal interfaces. We can work with our test tools. We can work with the other vendors' test tools. We have Selenium interface, many different session types that can be captured. The interaction can be captured, the results can be captured, and easy analysis can be done. And with that, I'm going to hand it to Erwin, and he'll walk through a fairly simple demo to give you an idea of what the tool looks like and how we spin out a VM. And while he's unplugging here, if you have any other questions, we can answer them.
How long has this platform been out there? And I'm guessing that you're probably getting a pretty serious uptick in people asking about it now with the rise in CI and traditional, dev shops now, or new dev shops, and it's becoming the new tradition.
The core tool has been out there for 7 years. We're continuing to build components of the whole ecosystem. But the core authoring and analysis environment, which we call iTest Enterprise, has been out there for a while. We just last year launched the lab orchestration piece of it. This year we'll be adding virtual lab orchestration to that lab piece. And then we have a test execution environment, which is one of the other key missing pieces that we had from. So if you have authoring and you have analysis building, the asset building, you still need a way to schedule those, and that's the piece of the tool that's coming out this year. So yeah, we're getting. We have a lot of interest in the original tool, but we also have even more interest in the whole solution portfolio, which helps to do the continuous integration type environment.
Yes, it's nice. I mean, we're doing those manual steps in a lot of ways, but actually having the proper end-to-end gated commits, guaranteed tests that are attached to it, so you know for sure that it's it's real. It's more and more folks I'm talking to are latching on to that and really getting to it. We're closer, like even in the space that we work in, we write a lot of scripts. We do a lot of small things, and then those scripts move into recipes. Those recipes move into other testing frameworks, and then we retest our testing. We are starting to do that even on the infrastructure side. Infrastructure, though, is still a little bit of a, that infrastructure as code's still a little light in the pure VMware environments, because we still are just freshly coming into cloud automation, more use of the automation tools that are there. But yeah, again, in the raw development shops, they've already latched onto a lot of this stuff, and it's really hopped up, I find, in the last sort of 24 months.
And we don't have it as part of the demo, but if we have time, we can show it. Even the folks that write scripts and they see this tool, one of the things that they catch on to real quick is our response analysis technology. And usually you're writing some type of regex expression, and you're debugging it, and it's not giving you the right answer, and you spend a couple hours trying to figure out how to extract that processor type out of this big piece of code. That's one of the key pieces of power of iTest, is that it takes something that could have taken you an hour in Tickle to do if you're really good at Tickle, and you can do it in 1 or 2 minutes in iTest and get that result. And if the response changes down the line, you're not again trying to spend 45 minutes to an hour changing your Tickle. All you have to do is visually say, hey, here's the result now, and the tool can pull the result out. So just improving the time you spent doing regex is where we can help in the simplest case.
That goes to the classic thing. I said, if you have a problem and you try and solve it with regex, then you now have 2 problems.
Yeah, exactly.
Yeah, and I actually added a sample of what Jim is saying, so I just was sitting in the back and I thought I saw him putting it on there, so.
Perfect.